Omnicon is a multi-parameter measurement and controlling device that can do the job only by itself, even in a situation that two or more devices are needed in the same process. Omnicon control device is capable of monitoring and controlling a variety of parameters including pH, ORP, TDS, ozone, conductivity, free chlorine, total chlorine, combined chlorine, chlorine dioxide, hydrogen peroxide, peracetic acid, dissolved oxygen, turbidity, humidity, and temperature. Thanks to Omnicon's configurable structure, it allows users to use measurement parameters suitable for their companies and modify it. According to application needs, it can be customized during ordering process. Omnicon multi-parameter measurement and control device allows us to measure up to 6 different parameters relating to the process determined by the user, and these 6 parameters can be shown on the same screen at the same time. According to customer request, an additional analog output module can be added to the device, and users can get adjustable 4 pieces 420 mA analog outputs. These analog outputs can be programmed as linear output, pulse width, limit switch, reduce, and boost. Be sure that analog output module is always inserted to third slot. Omnicon has got 4 programmable relay outputs and 1 alarm relay output. These 4 relay outputs can be used as reduce, boost, PID reduce, PID boost, entering relay opening time, transition between relays, adjustment of preferred relay to the preferred measurement channel, making daily, weekly, monthly relay program with timer property. Omnicon has also 5 programmable digital inputs. These can be used for liquid level, flow switch, counter, and external alarm. In Omnicon, Modbus RTU and Modbus TCP communication protocols can be used. In addition, the analog output module can also provide 420 mA analog data transfer. Omnicon hosts a web server inside. With static IP, parameters can be monitored remotely through the web interface. Over web interface, operating status of the relays can be adjusted. Set values can be set. Retrospective records can be seen and checked on the graphic. Each measured parameter can be saved to your computer as PDF folder. Sensors are simple to install and operate, have no moving parts, and do not require a monthly replacement of regions. We will demonstrate the easy setup and calibration of Omnicon free chlorine monitor, which consists of a free chlorine sensor and a sample flow cell. It only takes a few minutes to assemble the sensor or to perform any routine maintenance. The sensor kit includes a probe with a membrane cap, a 1-year supply of electrolyte, and a single piece of blue abrasive paper. Certain precautionary measures must be taken. Before a membrane cap is ever removed, it is critical to slide the elastic seal away from the tiny vent hole. Failure to do so can result in permanent damage to the membrane. Also, do not touch the membrane surface, which is located on the tip of the cap, or gray-colored reference electrode. The assembly process is quite simple. Clean the working electrolyte by placing the blue abrasive paper flat on a paper towel, and run the tip across the paper 2 or 3 times to clean the gold surface. Slowly fill the membrane cap to the edge with electrolyte gel, not allowing any air bubbles to form. Hold the probe body upright while inserting it slowly into the membrane cap. and screw the cap onto the probe. Rinse off any excess electrolyte that escapes from the top of the cap and through the vents, and then dry the probe exterior. Now be certain the membrane cap has been hand tightened as far as it will go. Finally, slide the elastic seal into the slotted position over the vent hole, making sure that the seal is seated correctly and not twisted. Make sure the Omnicon is plugged before installing the prepared sensor into the system. Insert the parts that taken from the sensor housing in the order as shown. Place the sensor in the housing. Adjust the sensor position distance as 2 cm between membrane tip and water supply point. Secure the sensor in place by tightening the retainer sleeve. There mustn't be pressure in the sample chamber, and sample outlet should flow directly into an atmospheric drain. Slowly open the water inlet valve after making sure that the water outlet valve is open. Adjust the water flow rate to 30 liters per hour. Make sure there is no air bubble on the sensor tip. Connect the sensor cable to the Omnicon and wait 2 hours. You have to wait 2 hours for sensor polarization time. Meanwhile, there must be free chlorine in the water at least 10% of the maximum range of the sensor. For example, if you use free chlorine sensor with 0 to 5 ppm range, there must be 0.5 ppm free chlorine in the water that you measure. And this water must pass through the sample chamber during 2 hours. 2 hours later, take a sample water in order to measure in your photometer and check free chlorine level of the water. Go to the calibration menu from the main screen. Your password is 4 times 2. Choose New Calibration section. You should see a row value close to the reading value on top of the screen. Enter the value that you read on the photometer in the field seen as BF2 and save it. Return to the main screen. On the main screen, you should see the value that has been read on the photometer with a maximum deviation of plus or minus 0.01. Insert the conductivity sensor into the corresponding connector on the Omnicon and slide the protective sleeve over it. Go to the calibration menu from the main screen. Your password is 4 times 2. Choose the EC section for conductivity. Choose the new calibration. You should use the conductivity calibration solution closest to the values you will measure in the process. For default settings, this value is 2764 microsiemens. Make sure the temperature of the liquid is 25 Celsius degrees. Immerse the sensor in the liquid and move it slowly. Make sure that the entire end of the sensor is in the liquid. At top of the screen, you will see the movement of the raw value read by the sensor. When the raw value approaches 2764 and fixed, press F4. Save the calibration and return to the main screen. Make sure that you see the value on the main screen that is very close to the value of the liquid in which the sensor is located. Place the sensor in the related housing and secure the sensor in place by tightening pipe gland. Insert the pH sensor into the corresponding connector on the Omnicon. Go to the calibration menu from the main screen. Your password is 4 times 2. Choose the pH section. Choose the new calibration. You have to make 2-point calibration for pH. Get ready pH 4 and pH 7 buffer solutions. And make sure the temperature of the liquids are 25 Celsius degrees. As indicated on the box V1 on the screen, immerse the sensor pH 4 solution. Make sure that the entire end of the sensor is in the liquid and move it. At top of the screen, you will see the movement of the raw value read by the sensor. When the raw value approaches 4 and is fixed, press F4. Use the F3 key, move the checkbox from V1 to V2. Wash the tip of the sensor with clean water and dry it with a napkin. Make sure the tip is not wet. As indicated on the box V2 on the screen, immerse the sensor in pH 7 solution. Make sure that the entire end of the sensor is in the liquid and move it. At top of the screen, you will see the movement of the raw value read by the sensor. When the raw value approaches 7 and is fixed, press F4. Save the calibration and return to the main screen. Make sure that you see the value on the main screen that is very close to the value of the liquid in which the sensor is located. Place the sensor in the related housing and secure the sensor in place by tightening pipe gland. Insert the ORP sensor into the corresponding connector on the Omnicon. Go to the calibration menu from the main screen. Your password is 4 times 2. Choose the ORP section. Choose the new calibration. Get ready 475 mV buffer solution as indicated on the box V2 on the screen. Make sure the temperature of the liquid is 25 Celsius degrees. Immerse the sensor in liquid. Make sure that the entire end of the sensor is in the liquid. At top of the screen, you will see the movement of the raw value read by the sensor. When the raw value approaches 475 and is fixed, press F4. Save the calibration and return to the main screen. Make sure that you see the value on the main screen that is very close to the value of the liquid in which the sensor is located. Place the sensor in the related housing and secure the sensor in place by tightening pipe gland. First open the outlet valve of the sample chamber. Then open the inlet valve and be sure to allow water flow.